Hello, followers of my YouTube channel. Welcome to today's video. In the last video, we have seen the first parts of this HEC GeoHMS modeling, or HEC GeoHMS for HEC HMS input, which is pre-processing. So in the last video, we have seen about fillings of the sinks. Okay, we have done fill sink, flow directions, flow accumulations, stream definition. We have defined our streams, and stream segmentation, as well as catchment definition and catchment polygon processing. In addition, we have seen about drainage line processing, and also we have seen watershed aggregation, that means by adjoint catchment pre-processing. So I hope you have tried those processes which is available on the pre-processing stage on the HEC GeoHMS. Now for today's tutorial, we will see on the second part, which is project setup. Right, so we have seen those things in the last video. So to start with today's tutorial, so our task is to delineate our watershed, which means it is done by adding our outlet to a watershed. So generally we will follow these steps. So so the first thing here on the project setup is you should start your project. Okay, you should start your project. After that, we will generate our project by adding the outlets of the watershed. Alright, let us go. So go to this project setup. By the way, your folder, it's better to save your folder on the on your laptop. It's mostly advisable on C, D or C. For my case, it is located on D. Okay, so since it needs some spaces, so you should save your working directory on this local disk. It may be E, or for your okay, laptop. Okay, it is better to save on local disk D, E. So go to this project setup. So start your new project. Okay, start your new project, and accept the default. The project area is project area, the project point is project point. Let us accept the default here, and after that some window is available here, right? The window this sound is define a new project window is now available. You see the project name, so let me use this one. The project name here is GeoHMS, so it is a project name. Okay, it's a project name. Go to this one, and we can write like GeoHMS, and this one is HEC GeoHMS GeoHMS. You can copy and paste here. It is the descriptions of the project, and you can also select the extraction method here. Let us use this the default, and you can see the location here is on A. The folder is HEC GeoHMS and HEC HMS modeling. Okay, so save your project here, and it says the project GeoHMS has been successfully defined. Its size. Say okay. So we have defined our project now, and after that we can add our outlet. Add your outlet here. Add your outlet in such a way. This is the outlets of the watershed. Okay. Let us reduce the size here. Yeah, this is outlets of the Gilgil Abai watershed. And if you uncheck this one, and the second step here is you can zoom and add some adding point, add a project point. Okay, this one, add a project. By using this icon, you should give an outlet for your watershed. Okay, so this is for reference. It helps to helps you to helps us as a reference point for your outlet, but you should add a project point by using this icon. So to do that, you should first zoom in. If you uncheck those remaining parts, I mean the if you uncheck those things, you see should have this outlet. Therefore, you can work on that. But I have previously had some point here, so let me add parallel with this one. I will show you how you are adding it. Let me first delete this part. Start edit project point, then okay, and wait a minute. You see, this is the outlets of the watershed. This is a drainage line, but this one is a sail on the drainage line. You can select any point on this sail, and you can use as a project point. So let us delete this one, and I will show you how you can add add a point. Okay, so parallel with this one, you can add first you can save your edit and stop your edit here. So go to this add project point, then the point around this. You can use this one also, but let me add at the center of this sail. This one is the outlets of the watershed I'm considering. So give the name as Gil outlet, Gil out. Alright, you can say that Gil outlet in such a way, and save your work here. So we have given an outlet point for the project. This helps us as a reference point, but this the point what I have given now is considered as the watershed outlet. Therefore, go to this project setup, then new project. Now we have now generating a project. Okay, we have now generating our project. Let us see. You see our project. This one is this shaded area. Shaded area is a watershed boundary or the watershed. So if you have not correct, by default, if you know the shape of the watershed, you can cancel and make some correction for your outlet. If your shape is now okay, you can proceed. Since I know that the shape of the Gilgil Abai watershed is like this, and I want to create the project area, so I would like to say yes. Now, by default, a new layer here, Abai Gil Abai layer is now created. You see, and this generate window here. The generate window is now available here. the main view DM is main view DM, row DM is row DM. Alright, hydro DM is field, the field. So you can use the default one. And also the flow accumulation, stream grids, streamline grids, catchment grid. Here is sub-basin outlet. You see the outlet, so the sub-basin is sub-basin number 101, and the project point here is project point 101, and similarly the river here is river 101. You see, this is some informations. You can use those informations. We will see from the table of contents. So using those defaultly selected parameters, say okay. So wait, and we have now generating our project, our HEC GeoHMS project. Good, that's interesting. Let us wait. Good, so our project is now generated successfully, as you see here. Say okay. If you see here a new layer called GeoHMS. When we are creating a new project, we have given a project name as well as description. The project name is called GeoHMS. That is why the new layer is now available here. So we have this watershed. So we have delineated our watershed. You see that the river river 101 is at the outlets of our watershed. We can see that we can this is inactive. To observe some features here, you go to this layer and right click here, activate. You see, we can see some features under this one. Okay, you can see some features. So our watershed is now delineated in such a way. This shaded area, the shaded area contributes to this outlets of the watershed. So this is outlets of the watershed, and since we are working on this GeoHMS, you should activate this one, and you can work on it in such a way. So zoom to layer, and sorry, there is some disturbance. So we have this project in such a way. We can see the catchments, okay, the catchments in such a way, the streams, alright, the flow accumulations, flow directions, and the likes, okay, for also in this project. If you uncheck those things, you can also view some the catchments and the likes. Alright, you can see the flow accumulations, you can see flow directions here, the field DM here, and also the row DM in such a way. Those are this is the project point, that is outlets of the watershed, what we have added, and this is main DM, the main DM, what we have added before. Good. So let us proceed to our work now. This is delineated watershed now. These are the streams. If you open this sub watershed attributes of this watershed, we have around 200 25 sub watersheds are available, and we can also see the numbers of rivers here. If you open the attributes, there are around 25 rivers, since in each watershed there is streamlines, so that is available here. And let us proceed to the next step. Let us proceed. So we have created those things and see some characteristics. And the other main thing here also the basin processing. You can see here this is the basin processing. Under this you can see basin merge, sub-basin divided by maximum area, river merge, split basin at the confluence, and the like. So you can do those things in this basin processing. So let us do one thing here, which is a basin merge. Now to merge a basin, first, for instance, I would like to merge this and this subbasins as one. If you see here, those subbasins can be merged once. So to do that, go to this selection, select this one, by pressing Ctrl you can select the two by using shift. Okay, by pressing shift we can select the two subbasins once. After that, go to this basin processing, basin merge. You see that confirm if those subbasins is possible to merge. It says confirm to merge the displayed basins. So if you want to merge, say press yes. If you don't have an interest to merge, no, you can say that. If I say yes, now the two subbasins are merged and they are now one subbasin, one basin. If you open this one now, the number of subbasin is reduced from 25 with to that of 24. As we have seen before, the number of watersheds subbasins, open at review table, you see now the number of watershed should be reduced now. Let me save it. In such a way we can reduce the number of watersheds, since it may be difficult to manage. Okay, so we can merge it in such a way. And after you have merged it, you can also use a subdivided basin. If one basin is now, if it is large, we can divide that into two. Okay, we can divide into two by using subdivide basin processing. There is basin divide. Alright, we can use this one, and also we can merge rivers in such a way. So this is the main idea here. If you have an idea, we can see some things in the like. And the other is we can see river profiles. For instance, if you zoom this one, and I would like to see the river profiles of this one, go to this icon. Okay, let me check this editor. Yeah, this one is add project point. This one is identify contributing areas. This one is a basin divide. We can use this basin divide. Alright, this is a river profile. If you open this one, we can observe the river profile. Okay, if you say okay, this is a river profile, which is the elevations in the y, and x, this is the let me show you the river profiles of this river. For instance, the river profiles of this one. Alright, you can see that. See the elevation, and this one is the distance in meters. This means around 18 kilometer, the distance from this one to this one, this river. Okay, this river has such, let me reduce the size in such a way. good. Anyways, we can observe the river profiles by using this river profile. By selecting only the river in such a way, can observe the river profiles. And the other thing here is we can also extract river lengths. Can also extract the river lengths. For instance, if you open the attribute table of these rivers, if you open the attribute table, we don't have any information here. We don't have any information. Shape lengths, there are shape lengths. The shape lengths of rivers are available. You can use this one. And there is a slopes, elevation up slope and down slopes. And there is river lengths. There is other things are available here. So we can let us find the river lengths, this one. So to do that, first go to this. Let us use this river lengths. This manual. Go to this characteristics, and there is a river lengths. So to do that, go to these characteristics. There is river lengths here, and the input river is this riv 101. All the rivers are included in the attribute table, so you should select this one. Default is selected. Say OK here. Now the river lengths for each rivers are now calculated. If you see the attribute table, open the attribute table. Now the river lane is now calculated. You see, the river lane is now calculated in such a way. The river length is now so the length of this river from this up to this is this much in meter. All right. And also we can determine the river slope. We can also do that. Before doing the river slope on this, you should have to first do some tasks. Okay, so we can also determine the river slope. So go to this characteristics, river slope, and you can calculate those things. Okay, you can calculate those things. Go to this characteristics, river slope. So the input RODM is RODM. The input river is river 101. So say OK. With some certainties, we can get the river slope. If you open the attribute table here, you should have the up slope, down slope, and the likes in the slope here. Okay, this is slope. Channel bed slope. This one is a bed slope. It is a up slope and it is a down slope. We can also determine those things, and also we can determine the basin slopes. Also the basin slope. So to determine the basin slope, can also determine the basin slope. You should have to go to this arc toolbox. There is arc hydro tools here in processing, and there is a slope. You can determine the slope first on that. So go to this arc toolbox, and there is arc hydro tool here, and there is theorem pre-processing here, and there is slope here. The input is RODM, and the output is this one, this watershed slope. and it is percent rise. Is it a percent rise or not percent rise? So let us determine the watershed slope. So we have watershed slope. We have determined the watershed slope. So to determine the basin slope, go to these characteristics, the basin slope, and the input input slope grid is the watershed slope. So you should have to find the input soil grid here, slope grid. Go to your working folder. My folder is located on A, and which is under HEC GeoHMS and HEC HMS, and there is HEC GeoHMS database here, not this one. It may be from Google database, not this one. Not this one. On layers. Alright. Okay. Alright. It may be available here. So you should select that watershed watershed slope. Let me watershed slope is located on your folder, on your working folder. So go to this folder, then go to your working directory here, A, in HEC GeoHMS and HEC HMS. There is Galabai. So you can give this watershed slope, say add. So you can work on that. Now the basin slope is now determined. The basin slope is now determined. We can check in such a way. Okay, so we can also determine some other features. Let me see the basin slope here. Open attribute table. Okay, and there is maybe available here. This is the basin slope. You see, it is a very basin slope. A basin slope, very basin slope. It is very simple. And the other task is here is determining the longest flow path. We can determine the longest flow path. Go to these characteristics, longest flow path. The input features are now selected. Say OK. So we have we can see the longest flow path on each sub-watersheds. Alright, so you know that the longest flow path helps to determine the time of concentration. On computing the stream flow. We will see on the HEC HMS. So we can see the longest flow path for this watershed. The longest flow path is this one. Alright, and for this watershed, this one is the longest flow path. In such a way, we can know the longest flow path of the rivers. And the other thing here is you can also see on you can see the characteristics, the attribute tables of this one. Attribute table, open that. You may have these parameters. Okay, and it has its own hydro-ID for each rivers. Good. So we have determined the longest flow path, and we can also determine basin centroid. The centroids of the basin. This is one sub-basin, so we can determine which is the centroid of the basin, and also the elevation of the centroid elevation. Let me find that. So go to these characteristics, basin centroid, and the input here is the center of gravity. It is worked by using the center of gravity method. You know that center of gravity mean. Please read more about it. So based on the center of gravity, the model calculates the centroids of the watersheds. So say OK here, and we can see the centroids of each watershed. It's represented by this star. You see, if you uncheck these rivers, so this one is the centroids of this watershed, and this one is the centroids of this watershed. This one is the centroids of this watershed. Alright, so you can also determine the elevation as the centroids of this watershed. So go to this characteristics is the basin centroidal elevation. Centroidal elevations, RODM is selected, centroid 101 is selected. Now say OK, and we can observe that you can see from the attribute. If you open the attributes of this one, we have an elevation. Before we are doing the elevation, we have only drain ID, but now we have also centroidal elevations. For instance, if you select this one, or let me select this one, wait a minute, you see this one is selected. So the elevation at this point, is 2007 meter above sea level. Good, it's interesting, man. And also the other thing here is you can also we have also centroidal longest flow path. We can also determine the longest flow path up to the centroid, of the watersheds. Okay, using this centroidal longest flow path, and go to this characteristics. Similarly, centroidal longest flow path, and this is a basin. It's better to activate if I am inactivate, but I have doing well. And centroidal longest flow path, the watershed centroidal longest flow path. Okay, so it is better to activate this one, and centroidal longest flow path. Okay, so we can get the longest flow path up to the centroid. Okay, if you uncheck this one, we have the centroidal longest flow path. If you draw parallel line with this one, see the longest flow path up to the centroid. And similarly for this one, in the likes. I hope it is very simple and direct forward. You can try on your own. And we have seen up to the characteristics of the centroid for today's tutorial. So for the coming tutorial, we will see the remaining parts of this HEC GeoHMS modeling. And thank you for watching. Don't forget to share and subscribe the channel. If you have any questions, you can write your questions on the comment section. Have a nice time. Thank you. Bye. Nice to meet you. Bye.